For nearly 2 decades, U.S. space had to depend entirely on Russian rocket engine supply, and that is why the Americans have repeatedly had to endure extravagant threats from Russia. However, everything has changed when Elon Musk founded SpaceX. The long-maintained dominance of Russian space tech has been immediately overshadowed by Elon Musk SpaceX. All the glory of Russia is a thing of the past. SpaceX has developed the Raptor engine with ambitions of replacing Russia, and they succeeded. Sanctions introduced during the war between Russia and Ukraine and the aftermath made it clear. Now Russia has finally realized that its best engine is no longer the best one. It was replaced by SpaceX engines. So how has Elon Musk Raptor obsoleted Russia's best engine? Well, let's find out in today's episode of Alpha Tech. Let's start with the pride of the Russian rocket industry, the RD-180 rocket engine. The RD-180, as the engine is called, was built by NPO Energomash in a factory outside Moscow, in a marriage that would have been unimaginable at the height of the space race. A Russian space engine was powering a famous American rocket, the Atlas V. The RD-180 is remarkable not only for the geopolitical peculiarities of its rise to prominence, but because it was in so many ways simply better than any other rocket engine of its time. Remember, I only mentioned that it was the best at that time. Now, if you want to understand what made the RD-180 such a good engine, it helps to understand that there is a great deal of craft involved. Though hundreds of people collaborate on rocket engines, having someone with an instinct for good design in charge is vital. The trade-offs are too complex to be figured out by brute force or committee. In the case of the RD-180, that someone was named Valentin Glushko. After the USSR lost to America in the race to the moon, designing the best possible rocket engine became a national priority, according to Vadim Lukashevich, an aerospace engineer and Russian space historian. Soviet leaders wanted to build the world's most powerful rocket, the Inertia, to sustain the space stations in Earth orbit and to lift the Buran, a would-be Russian space shuttle. Glushko was given resources to build the best engine he could, and he was good at building engines. The result was the RD-170, the RD-180's older brother. The RD-170 and RD-180 have a big advantage. They're oxygen-rich, which means exactly what it sounds like. They inject extra oxygen into the system. Oxygen-rich engines tend to burn cleaner and ignite more easily. They also make possible higher combustion chamber pressures and thus better performance, but they are more prone to explode. At that point, the U.S. even knew that they couldn't rely on Putin's Russia for this sensitive critical technology, but the Pentagon estimates it would take many years to wean itself off the Russian engine. The thought is that there will be no engine that could surpass the RD-180. But Elon Musk and SpaceX made this utopia possible. They created and developed the Raptor, which is superior to the RD-180 in every aspect. Frankly, in a way, Raptors are like an attempt to build a better violin than Stradivarius did using modern methods. SpaceX has access to better diagnostics and more sophisticated simulation techniques than Glushko did. Importantly, they're made in the USA. Possibly the greatest technical advantage these new engines have over RD-80 is that they use methane as fuel rather than kerosene, and the RD-180 does. Kerosene can gunk up the works of an engine after repeated use, and methane has a higher specific impulse and burns cleaner. It is also much easier in principle to synthesize on Mars, which Musk aims to do. However, the Raptor resembles the RDA-180 in that it feeds the pre-burner exhaust into the combustion chamber, ensuring that almost all the fuel and oxidizer stored in the rocket's tanks are used to generate thrust. The Raptor relies on a tweak to Glushko's approach. Both fuel-rich and oxidizer-rich flows power its turbopumps, theoretically resulting in maximum efficiency. Now, you can easily see how Raptor is better than RD-180 through the technical specifications. When in February of 2019, Elon Musk announced a successful test of SpaceX's Raptor engine, which is intended to power the company's next-generation rocket Starship, he bragged of the high pressure reached in the Raptor's thrust chamber, 269 bar. Musk said on Twitter that Raptor had exceeded the record held for several decades by the awesome Russian RD-180. And now SpaceX focuses on Raptor 2, which is the post-iterative development of the version of Raptor, but will have more power, according to Musk's latest announcement, as SpaceX continues to ramp up ground testing of the upgraded engine variant. Raptor 2 now operates routinely at 300 bar main chamber pressure. Notably, the production rate for Raptor 2 now had reached 1 per day and was expected to improve in the future. By way of comparison, the one-time propulsion leader in the United States, Aerojet Rocketdyne, has set a goal of building 4 RS-25 rocket engines for NASA's Space Launch System a year. The total thrust output at sea level is also a fair place to compare them. The Raptor currently is at 2,200 kilonewtons, and the RD-180 is at 4,150 kilonewtons, and the F-1 is still the king at 7,740 kilonewtons. Thrust is great, but what's maybe just as important when designing a rocket is the thrust-to-weight ratio, or how heavy the engine is compared to how much thrust it produces. A higher thrust-to-weight engine ultimately means less dead weight the rocket needs to lug around. The RD-180 is 78-1. The Raptor, however, is better here with an astonishing 200-1 thrust-to-weight ratio. Yeah, that's amazing. Truly amazing. The cost is also an aspect worth considering. The RD-180 is at $9.9 million per engine. In the Raptor in 2019, the cost of the engine was stated to be approaching $1 million. SpaceX plans to mass produce up to 500 Raptor engines per year, each costing less than $250,000. Impressively, Musk indicated that the Raptor 2 production cost was approximately half that of Raptor 1. Well, the cost is one thing, but another strong consideration for cost of the engine is whether or not it's reusable. And here, the RD-180, not reusable, or at least never reused, which is different from Raptors, which can be reused up to 50 flights. As a result, the SpaceX Raptor truly is an excellent engine. It beats Russia's best rocket in almost every aspect. What's more, the engine also completely helps the U.S. broomsticks to perform all the important tasks without any connection to Russia. The American future is better with Elon Musk's vision and his team's effort. All thanks to them for their contributions. Recently, the massive Super Heavy Booster 7, which has 33 Raptor engines, was transported to its orbital launch pad. Let's do the math. 33 Raptor V2 combined, Booster 7 should be able to produce up to 7,600 metric tons, which is about 16.8 pounds of thrust. Also on that day, it was lifted for the first time by chopsticks on the launch tower and placed on its launch mount. Seeing a rocket lifted with 33 Raptor 2 engines was indeed a sight to see. With its heat shield and all 33 Raptors installed, Booster 7 will be ready to kick off static fire testing almost as soon as possible. We hope all goes well, smoothly, and quickly. Elon Musk plans to have the first orbital flight this month, and then we can see the true power of the best engine ever. In 2001, Elon Musk was rocketless but had Martian ambitions, so Musk's rocket-buying team arrived at the Russian rocket negotiation. The third and final meeting happened back in Russia. Musk flew there with Cantrell prepared to purchase 3 ICBMs for $21 million. But to Musk's disappointment, the Russians now claim they wanted $21 million for each rocket, and then taunted Musk. They said, "Oh, little boy, you don't have the money?" This insulting event, however, played a part in inspiring Musk to found SpaceX. On the flight back, Musk said, "I think we can build a rocket ourselves." And now Russia is completely destroyed by Elon Musk SpaceX. In fact, Russia has lost billions of dollars in the rocket business to those they once despised. Let's start with the ISS race, the first time Russia's loss of rocket launch business became SpaceX gain. Since the space shuttle retired in July 2011, America was forced to depend on Russia to ensure the presence of Americans in space. As of April 2020, a total of 38 Americans had flown on 35 launches, one of which 2 years ago nearly ended in disaster, but which otherwise have been successful. Notably, Russian space launches themselves aren't cheap. NASA has bought flights for its astronauts on Soyuz at a cost of $86 million per seat. In total, America has to pay Russia up around $4 billion, an expensive amount to ensure continued American human spaceflight. However, the May 2020 flight of SpaceX's Crew Dragon ended the Russian gain. The successful Demo 2 mission returned spaceflight to U.S. soil for a considerably lower cost, just $55 million per seat. As a result, the Russian industry lost billions of dollars in the rocket launch business to Elon Musk and SpaceX. However, that's not the worst. A 2022 invasion of the Ukraine intended to reassert Russian relevance on the world stage, it's had the opposite effect in space. By destroying collaborations with Europe, Russia transformed itself into the world's first former space power. The early years of the race were often led by the Soviet Union, as it raced to beat the U.S. and launched its first satellite and the first astronaut and made considerable advancements in rocketry. After the Soviet Union fell in 1991, Roscosmos also inherited rocket technology. By the early 1990s, updated versions of Soyuz, a Soviet rocket first launched in 1966, and Proton, a Soviet rocket launched in 1965, were still reliable and in use. The European Space Agency was concerned at the time that it could not maintain access to space by relying on its own rockets or American ones. In 1996, an arrangement was forged so that France-based Arianespace SA, the world's first private launch company, could market and operate Soyuz rockets. Roscosmos and the Europeans agreed a few years later to build launch facilities for the Soyuz at the French-operated European spaceport in French Guiana. It was a winning deal. Europe gained access to launch services, and Russia received an important financial lifeline. As recently as 2013, Russia controlled about half of the global commercial launch industry. But competition loomed. During the 2000s, SpaceX, founded by the electric car pioneer Elon Musk on the belief that rockets don't need to be monopolized by state-backed contractors, drove a 20-fold reduction in the cost of a commercial launch. By 2020, SpaceX represented half of the commercial satellite launch market, and Russia down to 10%. That was a problem. Over the years, as Russia's economy struggled, Roscosmos had leaned on commercial activity for funding. As businesses moved elsewhere, the funding suffered. Between 2014 and 2020, Roscosmos' budget fell from $5 billion to $1.4 billion, and NASA's 2021 budget was $23.3 billion. Last year, President Vladimir Putin declared that Russia needed to master new rocket technology to compete for commercial space launches against SpaceX, and then proceeded to cut funding for the spaceflight activities even more. Roscosmos could still count on the ISS and its commercial collaborations with Europe for financing. The most important European example was a record $1 billion contract signed by OneWeb, a British satellite broadband provider, for 21 launches via Arianespace. Then Russia invades Ukraine, drawing sanctions from the European Union and the UK. Roscosmos responds by suspending rocket operations and recalling Russian staff from the French Guiana spaceport. That left 4 European satellites and 1 space telescope in search of new launch vehicles. A few days later, Roscosmos informed OneWeb it would not launch its satellites unless it received guarantees that the satellites would not be used for military purposes, and the UK government would divest from OneWeb ownership. OneWeb responded by hiring SpaceX to take Russia's place. The European Space Agency informed Russia it would no longer collaborate on a joint Mars mission, which it can afford to pursue alone. Roscosmos cannot. Amid sanctions and Russia's belligerence toward its European partners, who would hire them? It leaves a once proud space program with no apparent way to remain relevant as a space power. And add fuel to the proverbial fire, the U.S. RD-180 rocket engine servicing, one of the crucial sources of funding for Roscosmos, was severed by themselves. According to a Russian state news agency, TASS, Russian company Energomash, which builds rocket engines for both Roscosmos and export, sold its RD-180 engine to ULA for about $9.9 million apiece. As Dmitry Rogozin, the previous head of Roscosmos and a hardliner known for his tough statement against the West, said, Russia has delivered 122 of the RD-180 engines to the U.S. since the 1990s, equivalent to taking in more than $1.2 billion. 98 engines which had been used, but Russia would no longer be servicing the remaining 24. Roscosmos also said in a tweet referencing the interview with Mr. Rogozin that it would cease selling engines to the U.S. Perhaps in Rogozin's mind, the U.S. still depends on the supply of Russian rocket engines, and to stop supplying them is retaliation for U.S. sanctions against Russia over the invasion of Ukraine. Sadly, things didn't turn out the way Rogozin thought. U.S. Air Force Secretary Frank Kendall said U.S. national security launches will not be affected by the Russian decision. "I think our launch needs will be met," Kendall told reporters on March 3rd at the Air Force Association's Air Wayfare Symposium. Why are they so confident? Well, it's because they have SpaceX. SpaceX designed and manufactured their own rocket engines. What's more, they built the first methane engine ever to fly. Yep, we're talking about the Raptor engine. At the rate of producing an engine per day, and as a quick note, this productivity is improving day by day. SpaceX not only has enough engines to power its own rockets, but it can supply other parties. Therefore, Russia's decision makes no sense to the U.S. On the contrary, Russian space itself depends on rocket engine supplies to the U.S. And that decision to stop selling has caused the already narrow source of income to be exhausted. The industry, which was deeply hurt by Western sanctions, is now becoming more and more difficult because of their increasingly dried-up financial resources. So whatever route new Russian leadership takes back to space, it's unlikely to restore the nation's status as a space pioneer. Instead, thanks to SpaceX and the Ukraine, Russia becomes history's first outer space also-ran. When the American company General Dynamics announced a competition for engines for its Atlas III and V rockets in 1996, everyone was shocked when it announced that the winner was the RD-180. All engine production is concentrated in Russia. Engine sales were once through the roof through a joint venture between Pratt & Whitney and NPO Energomash. However, since the sanctions of May 2014 and on the basis of a lawsuit filed by Elon Musk and SpaceX, a court order has temporarily suspended the conclusion of new contracts. But on the basis of old contracts, engine deliveries have continued. Although NASA was eager to copy the Russian engine, they didn't succeed, at least not with satisfactory results, after they spent about $1 billion in 5 years. That is, until the new Elon Musk engines. And now SpaceX's new-gen engine will absolutely outclass Russia's best engine. 8 years ago, Elon Musk was right to warn the U.S. about its relationship with Russia in the rocket industry. At that time, Russian Deputy Prime Minister Dmitry Rogozin sent shockwaves through the space industry when he announced Russia would no longer supply rocket engines to the U.S. Buying Russian-made RD-180 engines was seen as a good idea in the aftermath of the Cold War, especially when relations between the U.S. and Russia had thawed, and developing domestic RD-180s would have meant a significant investment from the U.S. government. The U.S. is licensed to produce a domestic version of the RD-180 if it chooses to, but due to a lack of investment from the government and industry, it's never done so. It's a decision that was coming back to haunt the U.S. space industry as it clambers to find alternative ways to power the Atlas V. An unpublished Pentagon study written by retired Air Force Major General Mitch Mitchell in May of 2014 said an eventual Atlas V grounding would delay as many as 31 missions and cost the U.S. nearly $5 billion. More seriously, Brian Harvey, an author of several space books, shared, "For the Americans not to take RD-180s anymore would probably be quite disruptive of their space program in the medium term." Everyone was worried and trying to hold on to Russia, except SpaceX CEO Elon Musk, who rattled the U.S. military space launch market, challenging the monopoly of the ULA by suing the U.S. Air Force. Referencing the U.S. dependency on the RD-180 and sanctions against Rogozin, SpaceX's court complaint read, "It is hard to imagine any way in which entrenching reliance on Russian rocket engines while funding the Russian military-industrial complex with U.S. tax dollars serves national security interest, especially at a time when the administration has sanctioned individuals associated with the same military-industrial complex over the Ukraine annexation." This definitely became a helpful warning for the U.S., and finally, and on the basis of a lawsuit filed by SpaceX, a court order has temporarily suspended the conclusion of new contracts, but on the basis of old contracts, engine deliveries have continued. As a result, studies began for a next-generation rocket engine in the U.S. Elon Musk not only talked, but he also acted. And finally, SpaceX has succeeded with the Raptor engine which is superior to the RD-180 in every aspect. In the current situation, when the U.S.-Russia relationship really reached a dead end, it wouldn't be an exaggeration to say that SpaceX is the government's savior. Notably, Elon Musk mocked Russia as the country that said it would stop providing rocket engines to the U.S. in retaliation to sanctions placed on it for invading Ukraine. So why can Elon be so confident? How does his engine outclass Russia's best rocket engine? Raptor was publicly discussed by SpaceX's Max Bozoff at the American Institute of Aeronautics and Astronautics Commercial Crew Cargo Symposium in 2009. Until now, the latest version of SpaceX Raptor, called Raptor 2, was developed and manufactured for use on the in-development SpaceX Starship. Raptors use the so-called full-flow combustion cycle, which means that all oxygen drives the oxygen turbopump and the fuel drives the methane turbopump. Elon Musk confirmed that the production had reached 7 engines per week. On the other hand, the Russian RD-180 is a completely different story. It's larger and much heavier than the Raptor, manufactured in the early 90s. In a way, Raptors are like an attempt to build a better violin than Stradivarius did using modern methods. SpaceX has access to better diagnostics and more sophisticated simulation techniques than Russia did. Both are technologically based on the previous generation design for the Buran program. That's why the Raptor resembles the RD-180 in that it feeds the pre-burner exhaust into the combustion chamber, ensuring that almost all the fuel and oxidizer stored in the rocket's tanks are used to generate thrust. Honestly, the Raptor also relies on a tweak to Russia's approach. Both fuel-rich and oxidizer-rich flows power the turbopumps, theoretically resulting in maximal efficiency. Possibly the greatest technical advantage the Raptor has over the RD-180 is that they use methane as a fuel other than kerosene, which the RD-180 does. Kerosene will just gunk up the works of an engine after repeated use. Methane has a higher specific impulse and burns cleaner. It's also much easier in principle to synthesize on Mars, which Musk aims to do. Finally, it's necessary to discuss the specs of the SpaceX Raptor and RD-180. For context, on February 10, 2019, just days after SpaceX began testing its first full-scale Raptor prototype ever completed, the engine briefly reached a main combustion chamber pressure just shy of 269 bar. That narrowly beat records set by Russia's RD-270 and RD-180 engines. According to the latest announcement by Musk, as SpaceX continues to ramp up ground testing of the upgraded engine variant, Raptor 2 now operates routinely at 300 bar main chamber pressure. Raptor 2 produces a thrust of 230 tons by burning methane and LOX. The RD-180 generates 386 tons of sea-level thrust, but notably has 2 combustion chambers and 2 nozzles. It uses RP-1 kerosene and liquid oxygen. In other words, the Russian engine can be seen as one engine with 2 combustion chambers, or as 2 engines that share 1 turbopump. So let's imagine 2 Raptor engines. They can fit in the size of 1 RD-180, definitely creating much higher thrust. Next, the thrust-weight ratio at sea level for the RD-180 is around 80, while for the Raptor it's around 200, which means it's 2.5 times better. Raptor 2 current cost is around $1 million, but Musk promises it will drop to maybe $250,000 when serial production begins and when 3D printing of parts begins to be used. Until recently, the RD-180 cost was $9 to $10 million. Well, cost is one thing, but another strong consideration for the cost of the engine is whether or not it's reusable. And here, the RD-180 is not reusable, or at least has never been reused, which is different from the Raptor, which can be reused up to 50 flights. In short, SpaceX Raptor truly is an excellent engine. It'll completely help the U.S. broomsticks perform all the important tasks with no connection at all to Russia. And anyway, Rogozin should apologize for lying to himself and everyone else when he said the Russian engine is still the world's best rocket engine. Well, that just about wraps it up for today's episode. Hey, don't forget, share your ideas in the comments section because your support is motivation for us to create more quality content. Thanks, and we'll see you next time.